In this chapter, we've been solving quadratic equations. We've used a couple of methods. We've used square roots, we've used factoring, we've used completing the square. Now, the completing the square gives us a nice shortcut that we're going to learn today. It's called the quadratic formula. So, if we were to take our original format for a quadratic equation and leaving it as letters, complete the square on it, we would get down to this solution. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so that a, b, and c come directly from this form at the top. Okay, a is whatever the coefficient of x squared is, b is whatever the coefficient of x is, and c is whatever the constant is when you write it in this form. So before you use the quadratic formula, you need to make sure that your equation is written in this form so that you have your a, b, and c lined up. Then you just plug it in to the formula and simplify. You're going to want to memorize this formula because you're going to be using it for the next 5, 6, 7 years of math, assuming you take some in college, which you will because math is the best. Yeah, you're all agreeing so loudly. Yeah, now you're just sucking up. All right, so let's use, let's look at example 1 here. First equation they give us is 3x squared plus 5x equals 8. What's our first step? Isaiah?
Subtract the 8.
Subtract the 8 from both sides. So that rewrites it as 3x squared plus 5x minus 8 equals 0. Make sense? So, what's A? Yeah.
3.
3. What's B? 5. What's C?
Negative.
-8. Make sure the sign goes with it. So now it's time to plug it in to our quadratic formula. Now you have that there in your notes. So we should know what comes first. What comes first?
Be the negative 5.
Negative B, and in this case B is 5, so we got negative 5. Then what?
Plus or minus.
Plus or minus?
The square root.
Square root.
Of 5 to the second power minus 4 times 3 and then times negative 8.
Okay, what's on the bottom?
2 times 3.
2 times 3. So once we get everything plugged in, it's just a matter of simplifying. Now sometimes these will come out nice and neat, and you won't need your calculator. Sometimes they'll come out real messy. Let's see. First of all, what's 5 squared? We shouldn't need our calculator for that. And what's negative 4 times 3 times negative 8?
-6.
96. And we know that 2 times 3 is 6. What's 25 plus 96?
That would be
121. And what's the square root of 121? So we've got negative 5 plus or minus 11 over 6. So far, so good? All right, let's take our time. First thing we need to do is add. What's negative 5 plus 11? 6. What's negative 5 minus 11?
negative 16.
Negative 16. So what does 6 over 6 reduce to?
1.
And what does negative 16 over 6 reduce to?
No, negative
Reduce the fraction.
4. Negative 4 over 3.
Negative 8 thirds.
Thank you. Negative 8 thirds. 2 goes into 16 8 times. 2 goes into 6 3 times.
So we're supposed to keep the fractions as...
Well, this was a multiple choice question in the book, and the answers were fractions. But in general, it's a good idea to keep them as fractions.
I mean, like not.
Unless they're not going to be exact answers. Unless, in some cases, we'll have the square root of something that isn't a whole number. Let's look at example 2. Two x squared minus 7 equals x. What's my first step?
Subtract the x.
Subtract the x from both sides. Okay, so now we have it written in standard form. What's A?
2.
B?
-7.
Nope. Gotta make sure it's in order. -1. And what's C?
7. -7.
-7. So let's plug this into our quadratic formula. X equals, what's first?
-1. Negative, in parentheses, -1.
-1, which is +1. Plus or minus the square root of -1?
1.
-1
-1 squared.
squared minus 4 times what's next?
2.
2
And then times -7.
times -7.
Over 4.
Okay, what goes on the bottom? Spence.
2 times 2.
2 times 2 because A is 2. All right, so let's simplify. We've got 1 plus or minus. What's -1 squared? 1. What's -4 times 2 times -7? Yes.
-56. But, no, plus.
-4 times +2 times -7 should be +56. Okay. Now, what do we have under the radical? What does that add up to? Tyler? 57. So we're doing 1 plus the square root of 57 divided by 4, and 1 minus the square root of 57 divided by 4. Now make sure that when you plug this into your calculator, if you're doing it all as one step, you put the numerator in parentheses. Otherwise, you'll only be dividing the radical 57 by 4. So what do we get? Somebody give me the plus. Isaiah.
2.14.
2.14. What about the minus? Yeah.
-1.64.
-1.64. Now, plugging it into our calculator, right?
I did.
You didn't divide by -2, you got to divide by 4, not -2. 4 because we had 2 times 2 on the bottom. Right, because we had 2a, and a is 2, so that gives us 4 for a denominator. Make sense? So the question is, once we have all of these methods, which one do we use in each situation? Well, it depends on what you have. There's a nice summary on page 673 that tells us what to use and when. The first method that we actually learned last chapter. That was factoring. And we'll use factoring when you can factor it. Right? Because if you could factor, then factoring is usually the fastest method. You can use graphing if you only need an approximate, if you don't necessarily need an exact, and you can do that right in your calculator. You can use square roots as long as you don't have an x term. Okay, if you have an ax squared plus c equals 0, or an ax squared equals something, and there's no x term in the middle, then you can use square roots. Otherwise, you have to use completing the square or the quadratic formula. Now, I'm going to be honest, I never use completing the square to solve a quadratic equation. I do use it, and we use it more for graphing parabolas, and we'll get to that more when we get to algebra 2. But if I have to solve a quadratic equation that uses completing the square, you might as well just use the quadratic formula, because it's the shortcut around completing the square. Okay, and it helps avoid a lot of mistakes. So the key is to memorize that quadratic formula there. Okay, that's the important part. So let's look at some of the examples in number 3 and see which method we would use in each case. So here we have, in the first one, 10x squared minus 7 equals 0. What method might you use?
Finding the square roots.
Finding the square roots, because I can rearrange this. It doesn't have an x term. I can rearrange it by adding 7, dividing by 10, and now I just have to take the square root of both sides. Okay. So that's the fastest method for that one. Yes?
Can you ever leave your answers x equals radical 7 over 10?
You never leave a fraction under a radical. Okay, but we'll discuss that more when we get to rules of square roots. Okay, in this case, in this chapter, we're just using decimals. You just take the square root of 7/10 and write it as a decimal. How about this equation? Yeah.
By factor.
Why?
Because you can, if you can factor between, because they both have an x.
I can factor an x out. They both have something in common. And factoring is especially easy when there's no c term, okay, when there's no constant term. Because when there's no constant term, I can always factor out an x. Okay, and then remember I set x equal to 0 and x plus 4 equal to 0. And that gives me my two solutions. Okay. How about this one? Can we use square roots? No. So the next question is it factorable? So remember how we checked it. If it's factorable, we multiply 5 and negative 4. What does that give us?
Negative 20.
Now, are there factors of negative 20 that add up to positive 9?
No.
We know that they'd have to have different signs to multiply together to be negative, right? And if they're going to add to be positive, the bigger one would have to be positive. So we'd either need 20 and negative 1, or 10 and negative 2, or 5 and negative 4. Any of those add up to 9? Nope. So that one's not going to be an easy one to factor, so the quadratic formula is the best solution there. You could use completing the square, but again, really not the fastest way. Make sense? Any questions? Okay.